Okay, babies, as promised, your next video is going to consist of your transformation examples. So all we're doing for these, we're just reading the equation and we're listing the transformations in order. Remember, we're going to start with horizontal first. Oops, that should be a 1. Horizontal first and then vertical at the last. Okay, everything else in the middle doesn't matter. All right, so let's look at what's happening here. The first thing we're going to do, we're going to identify, and I know it doesn't tell you to do this, but I'm going to help you understand what you're doing here by doing this. Okay, if you'll notice, we have an x right here, and it is squared. That means we are dealing with a quadratic function. That means the graph that is formed is a parabola. So that's the name of the function. This is the graph it produces. This is just to help you. This is just to give you something to ground yourself with. Okay, so the first thing I'm going to do, I'm going to ask myself, is anything horizontal going on? Well, and the answer is yes, it is. Because if you'll notice in your parentheses right here, we have x minus 2. That means we have a right shift of 2. So that parabola moves to the right 2. What else is going on? Well, look at this 2 out here. That 2 indicates that we have a change in y by 2. So y change by 2. And you can think of it as the parabola stretching up to be skinnier. So you can think of it that way. But that is what's happening. Okay, so as we look at the next example, notice we've got an absolute value function here. So absolute value, this is the name of the function. And it doesn't really have a shape per se, but it usually looks like a big V. All right, it usually looks that way. And then, of course, it'll shift around. So let's look at its transformations. So there are 3 things going on here. We've got this negative out front, we've got the x plus 4, and we've got this minus 7 right here. So I'm going to take care of the x plus 4 first. It's inside my absolute value bars, and those behave like parentheses for our purposes here. So we're going to shift left 4, and then we are going to have a reflection. So we have a reflection, that's what that negative out in front, and since it's outside of the absolute value bars, that means it's going to reflect along the x-axis, and then that negative 7 means that we are going to move down 7. So that's what that's going to look like. Okay, let's look at number 3. Number 3 is the doozy. Okay, this is the one that's going to challenge you. This is the square root function, and it just looks like this. It's got that curve. That's what that looks like. It really doesn't have a name, so the graph itself. All right, so several things are going on here. So let's look at this. We've got a shift, we've got a horizontal shift here. This negative means we've got a reflection, and this means that we've got a stretching or shrinking of some kind. The words there, I don't want you to get too caught up on, is it a stretch or is it a shrink? All I want you to really write is y by, because y is changing by, in this case, 1/3. Okay, so do we have a horizontal shift? Yes, we do. If you will notice, we have x minus 3 here. That means that we have a shift to the right of 3. And that negative in front of the x means that since it's not outside of the square root symbol or the radical, that means it reflects over the y-axis. And then, of course, y changes by 1/3. So essentially what is going to happen here, let me show you. I created it in Desmos, if I can find it. Here we go. So your original function, your parent function, is in blue over here to the right. And then if you'll notice, The other one is red. So if you can see that there, what happens is, see, I've got movement to the right, so I would move from the origin all the way over to the 3, then it reflects across y, and then it gets flatter because the y's are multiplied by 1/3 of what they normally are. So hopefully that makes sense to you when you see it that way. Okay, so now let's look at this last example. Okay, don't freak out. This is the reciprocal function, okay? When the variable x is in your denominator, you have the reciprocal function. And that's the one that looks like this, okay? It has an asymptote in it because it's got restricted values for x. So what is happening to the parent function in this particular situation? Well, there are 3 things happening. We've got this x minus 1 here. This -1, since it's associated with x, this means that it is going to shift to the right by 1. The 4 tells me that y changes by 4, and the +5 tells me that it shifts up by 5. So in the next video, we're going to talk about transforming graphs right down here. That's what we're going to do. And then we will have one last video. I know you're excited. Try to calm down.